Alright, so I'm going to show, this is on the Do You Know How in 6.2. I'm going to show you how to write an exponential model algebraically, because the only way I showed you in the video was how to solve it using exponential regression. So to do this, we know that our equation needs to be in the form of y is equal to a times b raised to the x. Well, we've got x, we've got y, we've got x, and we've got y. So I'm going to plug this in, and I'm going to say that I've got 55 is equal to a times b to the third, and 70 is equal to a times b to the fourth. And this is where we're going to use like a system of equations. So I'm going to solve for a. If I solve for a in this first equation, I get a is equal to 55 divided by b to the third. Well, now anywhere I have an a in the second equation, I'm going to plug in 55 divided by b to the third. So 70 is equal to 55 divided by b to the third times b to the fourth. Well, if you remember those exponent rules, they tell you if you've got, well, let me actually just kind of finish it out. So I got 70 is equal to 55 b to the fourth over b to the third. Your exponent rules told you that when you were dividing, you did what to the exponents? Anybody remember? If you divide, you subtract your exponents. So this becomes 70 is equal to 55 b. So y'all know how to solve for b. We take 70, and I'm going to round to two decimal places. 70 divided by 55. And I get 1.27 equals b. Well, that's all fine and dandy, but I need to know what a equals. Do y'all see this that I'm about to plug into? I know what b is, don't I? So to find a, I'm going to have to do my work over here where I've got a little room. I'm going to say a is equal to 55 divided by 1.27 to the third. Again, I'm rounding to two decimal places. 55 divided by 1.27 raised to the third. And I get 26.85. So I know what b equals. I know what a equals. So I can write my final equation. Y is equal to 26.85 times 1.27 to the x power. It's going to work the same down here for 10. We're going to have 12 is equal to a times b to the 7th. And 25 is equal to a times b to the 8th. Again, we solve for a. A equals 12 divided by b to the 7th. So 25 equals 12 over b to the 7th times b to the 8th. I'm going to kind of skip a step here. I know this is going to cancel out, and this is going to be left with just b. So now I've got 12b is equal to 25. .08 is equal to b. plug in for a, 12 divided by 2.08 to the 7th. And I get 0.07. So my final equation is y is equal to 0.07 times 2.08 to the x power. All right. Now we're going to move on to, we're going to do 2 lessons today, 6.3 and 6.4. They're very easy, lots of calculator uses. All right, so we're going to start on page 150. All right, so this just says, right, the logarithmic form of y is equal to 8 raised to the x power. That's the first time you've ever heard of a logarithm form. Right now we are in exponential form. 150. 150. So right now we are in this form where we've got b, which is our base. We've got our exponent is equal to our answer, right? And this is called exponential form. We want to rewrite it in logarithm form. So that would be log, small letter or small numbers b, in parentheses is going to be our a value, and we're going to set it equal to our e value. So let's look at what we have here. It's an exponential form. Y equals a, 8 equals b, and x equals e, right? If we're looking at the exponential form and comparing it. Y'all see where I got that? All right, now let's write it in logarithm form how they ask. So we'll write log. B is 8. A is y. And we set it equal to x, or e. And sometimes you may see the y in parentheses, or you may not see it in parentheses. Either one is correct, okay? Either way you write that would be correct. All right, now they want us to convert between logarithmic and exponential form. Right now, this one is in exponential form, so they want us to rewrite it in log form. So the 7 is which letter? B, E, or A? 7? B. What about the 3? E. And 343 is A, right? So when I rewrite it, it's log 7, 343, and we set it equal to 3. Any questions on how I got the numbers that I did? All right, now we are in logarithm form and we want to go to exponential form. So 4, which letter is that? B, E, or A?
B.
B. 16 is A. And 2 has to be E.
Oh, this is the reverse.
Yep, the reverse. So we've got 4. We raise it to the what power? Second, and we say it equals 16. Everybody got these two? All right, example 3 says, what is the value of each logarithmic expression? To the side here, I want you to write alpha, window, 5. This is why I said you're going to want a calculator. Alpha, window, 5. Well, you hit the green button, alpha, you hit the window button, and then you hit the number 5. Do you see it right here? And we just put it in there as it looks. Log base 3 of 181. Or 1 over 81, excuse me. And you hit enter, and it tells you what your answer is. Our answer here is -4. We do the same thing for B. And you probably got this, didn't you? So we're just going to write not or undefined. And then under it I even just wrote not possible. All right, we're going to do the same for C. And it tells us our answer is 9. Is everybody okay on those 3? Pretty easy, right? All right, in example 4, you see we both got log and natural log. Well, this is log and this is natural log, is what that is. And if you see just log of x, there is an understood base, or that small number, understood to be a 10. It's understood to have a base of 10. If you see the natural log of x or the natural log of any number, it's understood to have that natural base of e. Remember, we talked about that e in that compounding interest? And that's understood as natural log. All right, so this says, what is the value of each logarithmic expression to the nearest 10,000? If it just has log, though, if it just has log, all we have to do is put it in our calculator. You don't have to use that alpha window 5. Do y'all see this log button right here? to the left of the 7. Log of 321, close my parentheses, and I've got my answer here. My 10, they want us to the 10,000, so tenths, hundredths, thousands, 4 decimal places. 25065. All right, natural log is to the left of the 4. It's right below that. Did y'all see that one? All right, I'm going to hit LN and then 1215. And you should get 7.1025. You probably got a 4, but remember we're rounding, so what that 9 makes us round up, right? And then my next one, log of 0.17 is negative 0.7696. All right, example 5. Solve each equation round to the nearest thousandth. So right here, I've got log of 3x minus 2 is equal to 2. What did I say was an understood base for log? 10, right? So I'm going to rewrite this in exponential form. If I rewrite it in exponential form, this becomes 10 squared is equal to 3x minus 2. Well, 10 squared is 100, right? 10 times 10 is equal to 3x minus 2. So 102 is equal to 3x. So that means x equals 34. You can plug it back in to make sure. Log of 3 times 34 plus minus 2. And it gives us 2, so that is correct. All right, this one's in exponential form, but that's not really helping us because we are trying to solve for x. So we need to rewrite this so that it is in, well, the E is going to tell me I'm going to rewrite it in natural log. So this has become B, E, and A, right? So if my base is E, I know it's the natural log, okay? My base is E. So the natural log of 8 is equal to x plus 2. Because my base was an E, I knew that it was the natural log. So natural log of 8, we're rounding to the nearest thousandth. So 2.079 is equal to x plus 2. 2.079 minus 2 is 0.079 is equal to x. All right, for example 6, it says the seismic energy X in joules can be estimated based on the magnitude M of an earthquake by the formula X is equal to 10 raised to the 1.5 M plus 12. And then they wanted us to find the magnitude of an earthquake with a seismic energy of 1.8 times 10 raised to the 23rd. So, I know that X is equal to 10 raised to the 1.5 M plus 12. They gave us that equation. Or they gave us that formula. Well, something like that I would give you. Okay. Alright, we're going to substitute 1.8 times 10 raised to the third in for X. So 1.8 times 10 raised to the 23rd is equal to 10 raised to the 1.5 M plus 12. Now we want to solve the equation for M. Alright, we take the log of both sides. So I've got the log of 1.8 times 10 to the 23rd is equal to log of 10 raised to the 1.5 M plus 12. We haven't really talked about a whole lot of properties of logarithms, but this right here is a property of a logarithm because this is an understood base of what? Log has an understood base of 10, right? So if you've got a base of 10 and in your parentheses your number is the same as the base, they automatically cancel each other out, okay? So now I've got log of 1.8 times 10 to the 23rd is equal to 1.5 M plus 12. I think we had a problem earlier where it would have canceled it out. So, like for instance, well, it's just a base. It's a property. So, like, let's say I had log of 9 raised to the 9x, like that. You see how these two numbers are the same? So that would cancel out, and my answer would just be x. Okay? Does that make sense? A little more? Alright, so I'm going to approximate what this is. I've got log of 1.8 times 10 raised to the 23rd power. That's about 23.26 is approximately. What? Logarithm? Yeah. Yeah, I'll show you in a little bit. Because I'll show you how you can look at them on your online textbook. So I get 11.26 is approximately 1.5 M. So that means M is approximately 7.5 M. So the magnitude of that earthquake is about 7.5 M. Alright, and then I want you to just do numbers 5 through 12 on page 152. 5 page 12 on 152. And then we're going to look at the next lesson as well. Alright, graph each function and identify the domain and range. I'm going to go ahead and draw my set of axes. Alright, so I'm literally just going to put this in y equals and get my table, the natural log of x. Yep. Round to the 10th. 1.1, 1.4, 6. Yeah. That's fine. I mean, I just did it to save myself a little room. I'm sure you got the same numbers that I did. So I'm just going to graph these points. So 1, 0, 2.7, 3, 1.1, 4, 1.4. So if I graph it, I see how this graph looks. So our domain is any x value greater than 0. How do I know that? Because it doesn't go past this y-axis. My range, however, is going to cover every single y value, from negative infinity to positive infinity. So my range is going to be all the numbers. If we have any intercepts, I've got 1. It only crosses the x-axis once, right? I've got an intercept at x equals 1. What was your question, Mary? Mm-hmm. Yeah, all real numbers. Because it's going to keep going down, but then it's also going to keep going up. It asks us for our asymptote, so that's the line that it gets super close to but never touches. And there is only one of this, and that's right here on the y-axis, where x equals 0. And then it talks about your end behavior. So if x approaches 0, y approaches blank. As x approaches infinity, y approaches blank. So let's look. As x is getting closer and closer to 0, so that's closer and closer to this y-axis, our y values are getting smaller, right? Because it's going down. I see that? So we would write negative infinity. And as x is getting larger, it's going up this way. That also means that my y values, doesn't look like they're getting much larger, but they're slowly but surely getting much larger. So that would be positive infinity. Alright, this graph, I'm going to do the same thing. Alpha window 5, I'm going to put 1/2, log base 1/2 of x. Right, 1, 0, 2, -1, 3, -1.6, 4, -2, 5, -2.3, 6, -2.6, 7, -2.8, 8, -3, 9, -3, nope, 1, 0, 2, -1, 4, -2, 8, -3. If you want to do the ones in between, you can. I think it's easier when we graph whole numbers. And this is the shape our graph makes here. So again, this is our domain is the same because it's never going to cross this x-axis or this y-axis. So x has to be greater than 0. So that means our asymptote is x equals 0, which is the y-axis. We still cover every y value from positive infinity to from negative infinity to positive infinity, so that's all real numbers. We only cross the x-axis once, so my x-intercept is at x equals 1. Right, so as x is getting closer and closer to 0, if I follow this graph, x is getting closer to 0 as we go up. If we're going up, that means y is approaching positive infinity. In the opposite direction, as x is getting larger, y gets smaller, so y is approaching negative infinity. All right, they want us to describe how our graph compares to the graph of f of x equals the natural log of x. So the first one I have is f of x equals natural log of x plus 4. So compared to that red graph, what did the blue graph just do? Yep, it went higher, so it went up 4 units. So for 2, I'm just going to say up 4 units. So that's just like what we've been dealing with transformations, isn't it? So let's see what our next graph is going to do. F of x is equal to 5 times the natural log of x. And it's hard to see, but that was a stretch. So I'm going to say stretch by 5. All right, moving on to page 155. Do what? The last one was stretched by 5. All right, now we want to find the inverse of an exponential function. Remember, I think a couple days ago or last week or something, we found the inverse by switching x for y, or x and y, and then solving for y. We can do the same exact thing here. So I'm going to switch x and y. Remember, f of x is the same thing as y. So I'm going to write it as x equals 3 raised to the y plus 2. Remember, this is B, this is E, and this is A, right? So if we write this in logarithm form, so look, remember we had B to the E equals A, and log base B of A equals E. So if I rewrite it in log form, I now have log base 3 of x is equal to y plus 2. Well, how would I get y by itself? I would subtract 2, wouldn't I? So now I've got log base 3 of x minus 2 is equal to the inverse of y. So our inverse equation is log base 3 of x minus 2. All right, remember g of x is the same as y, so if I've got x is equal to log base 7 of y minus 2. First, I'm going to add 2 to both sides, so x plus 2 is equal to log base 7 of y. We've got b, we've got a, and we've got e. X plus 2 is one thing. So if I rewrite this, it would be 7 raised to the x plus 2 is equal to a, or y, or the inverse of y.